Hello everyone. Thank you for listening and participation on our EC492 capstone presentation here. So our group is targeted on designing a room monitoring and control system here. So I'm Yuyang.
I'm Yunyang.
I'm Yihui.
I'm Ruijun.
So let me first give you a brief introduction to our project. So as the fast development of the internet, the smart home appliance has been an essential part of our daily life. But at the same time, there's safety issues raises concerning about the data security and privacy. So our project is required to design and build a low-cost, extendable smart home control system that also enhance the data privacy and security without relying on the cloud services. So this project just addresses these issues by utilizing local processing. And our system provides a scalable and secure way to monitor room occupancy and other environmental conditions such as the humidity and temperature information. At the same time, it also offering an open application programming interface for integration and control. So overall, in one sentence, our project is targeted to build an open source extendable thermostat which is able to both provide room monitoring and control to sense the room occupancy and other environmental settings. So here I will also give you some introduction on the system architecture and components here. So for our project, we have two main devices here. The right side is our main hub, which is responsible for receiving and processing environmental data and visual features such as the photos like that collected from the satellite device. It also integrated ink module, which is for displaying the information we collected, such as the temperature, humidity, and human occupancy. And at the same time, the information is also like displayed on the website. And the left side is our satellite devices, which equipped with the temperature, humidity sensor, and the cameras. For the connection between the main hub and satellite devices, we utilize the MQTT protocol to send the data to the main hub, which also supports the scalability and secure connection. For the MQTT connection, we enable the MQTT connection by scanning the QR code that posted on the website from the main hub. And it also enhanced the end-to-end security. So all the data is processed locally, which ensures the data privacy and reduce reliance on cloud services, which is just fulfill our project's core security objectives. And for the system design, let Yunyang introduce his task on this.
So this is the system design of our project. There's two main parts of the project, the satellite devices and the main hub. The main hub provides a web page which is showing for administration information and the data monitoring. So the current device is a user's PC or a user's cell phone which access the web page on the main hub with a web browser. The external IoT device on the right side connect to the main hub with MQTT protocol, which is not implemented but planned for the future. For the main hub, it consists of MQTT stubs, the meter pipe which is a machine learning model for extracting the occupancy number, and the HTTP server is in the main hub. For the satellite, with all these sensors, it has software components such as the MQTT stubs, the QR code decoder, and several drivers for the sensors. This is the timeline of our project. As we can see that we have pretty long, around 1.5 months of planning and decision time, and also around 2 months for actually developing the project, which is showing in the red. Also, the blue one shows the planning and documentation times.
For the implementation and technology part that Ruijun introduced his task on this.
Okay, for the core hardware, we selected a Raspberry Pi 4B for the main hub core and the ESP32 CAN modules for the satellite. This can ensure low cost, efficient performance, and relatively good community support. For the software used, the MediaPipe machine learning model was incorporated. It can be used for real-time process, and the image captured by the satellite was sent back to the main hub and processed by this machine learning model. This model is having high efficiency and adaptivity. And for the data transmission, we implemented MQTT for the secure and efficient transmission between the main hub and satellite. And the acquired data was displayed on the e-ink screen of the main hub and a website hosted by the main hub as well.
And for the demo work, let Yunyang introduce the demonstration for our capstone project.
So this is our demonstration of the system. This here is the main hub. This one is the satellite device. So it features a custom shell around it, which is 3D printed. Here, this is the web from the main hub, which is hosted on the main hub, not on the cloud service. This is the terminal of the main hub. And this is the terminal of the satellite device. On the user side, the user only access to the website, which is hosted on the main hub. Users do not have access to the terminals. These terminals are only for the demonstration purpose. So the first step, user should connect the main hub to power and the Wi-Fi. The second step is to log on the website here. So on the website, there is sensor data which comes from the last run, and click the Q here. It shows the QR code which is required for setting up the satellite. The third step is to power on the satellite. As you can see, the satellite is powered on and waiting for a QR code. So we hold the satellite and then let it scan the QR code. The QR code contains the Wi-Fi information and the IP of the main hub so that they can connect. Well, let's just try it. Okay, so on the terminal you can see that the satellite device is connected to the main hub. Also, it starts to send the image and the sensor data back to the main hub. Let's go back to the previous page of the web. As we can see that the sensor data is going to run and is updated actively. So here I will just cover it so you can see the occupancy goes to 0. Well, let's try it. Oh, there's a person there. So right now the occupancy is 0 since it's not directing to anyone. And also, I just pointed to myself, and then you can see the occupancy is going up. Also, there is an ink screen on the main hub. If you push this button here, you can see it's refreshing with the data same with the website shown. So it's pointing down, so the camera did not detect any person, and because our room has some other person over there, so the occupancy is not very accurate. Let's try it again. So point to myself. So you can see the occupancy goes to 1, and then I cover it. The occupancy goes to 0. Yeah, that's all about the demonstration.
So for demands and solutions, first we concern about security concerns, address potential data spreadsheets between end-to-end encryption and local data storage, minimize extra exercise. And the hardware performance, carefully selection of cost-effective hardware like Raspberry Pi and SP32 ensures performance within budget constraints. And finally, the scalability issues. Develop a modular system with MQTT to enhance scalability, allowing easy addition of new satellite device.
So for the features and the future works, I first introduce what is working. So for the main hub, it basically is able to receive all kinds of data acquired and host an accessible website to display the data. And for the satellites, it is able to detect the data from its sensor and capture the visual feature, as well as the QR code, and decode it to connect with the same Wi-Fi as the main hub. And what didn't work is that, so for the website, we are able to present the QR code that indicates all the information of the Wi-Fi for the main hub currently is connecting, but we need to manually refresh it. For the alarm functions, it is planned to be good to have, but is not currently implemented. So for the desired future work, we plan to have an additional functional requirement, which is the alert system. The user is able to set an upper bound or lower bound for the environmental data or occupancy at a desired time. If the feature exceeds the desired range, for example, at 2 a.m., the occupancy is not 0 in your house, there might be a problem. And for the enhanced intercommunication, so currently we have unidirectional communication from the satellite to the main hub, enabling it to send all the acquired data. But the main hub cannot have any access to the satellite. So in the future, we plan to enable the operations like turning on and off the satellites remotely from the main hub. And for the third one, it is an improvement for the performance requirement. And currently, the main hub system is able to load data from 5 satellites. And in the future, we plan to upgrade the system to handle like more than 10 satellites. So that's basically it.
So, in conclusion, we basically did a successful implementation on our capstone project as required. So we achieved all the main goals on the security, data privacy, and system extensibility through effective design and technology application. So although most of our requirements are perfectly satisfied, there are still some future improvement we can make in the future, such as alert function and improve the scalability. So thank you for your attention.